Hi, Gapsters. Thank you so much for joining the first event of our DevQA Fusion Fest. Today we have Doug Wilson, who will be sharing with us the demo locally sourced artisanal data delivering foundational business agility. Doug is an experienced software application architect, music lover, and father of 4, who, among other things, founded Cygnus Technology Services, a Gap business partner, and recently served as the fractional CTO of Revealix, a food health startup and Gap client too. Doug is passionate about standardization, automation, and innovation, always striving for excellence and challenging the status quo. His notable achievements include leading the development of Fandango.com and the UK online lottery. Doug also writes on Medium, sharing insights on software architecture, communication, and AI. So, Doug, thank you so much for joining, and we are all ready to hear you.
Thanks, Chris. It's good to be here. Thanks everybody for your time today. And I want to share my entire screen because I'm going to be moving around between screens here. So let me reshare. Okay. So what I want to talk about today is this idea of business agility that is enabled by a good, clean, complete set of data. And one of the things that I've been working on for several years now is an open source product that I'd like to show today. Primarily, this isn't promoting the product, it's really talking about the best practices that are baked into this product. And kind of a bit of a smile around artisanal data. We don't usually think about something dry and necessary like data being artisanal. So a bit of a wink and a joke there. But the point of this is that today, carefully crafted, clear, consistent, and complete data sets are more and more important and valuable than ever, because in addition to making the applications that we design and build operate correctly, they're also used for reporting. That data is used for reporting, for analytics, for training AI models, all kinds of things that I refer to as downstream uses of this data. And so spending a bit of time to make sure that that data is captured completely and correctly from the very beginning is definitely worth some effort and some time. And hopefully I can make the case for that as we go through these slides. And I also want to pop around and show you some of the actual, like a live software demo, just so you can get a feel for how this works and how it looks, how the data comes out looking. Any questions? I want to encourage you as we go through this. If you have a question, you don't need to wait till the end. If you could raise your hand, and I think Chris will recognize you, and let's get that question addressed while we're at the spot. Okay. Great. Moving on to the next slide. So the product I mentioned is called the Adaptív Application Foundation.
Doug,
yeah.
I'm sorry to interrupt, but I think we're all seeing the Google Meet screen. Is that just me?
Yeah, we're seeing the latest.
Did I share the wrong screen?
I'm not sure. Let's try again.
Yeah, sorry about that. And is this any better?
That's better. Yeah.
Okay. Right. So you should be seeing a slide that says Adaptív Application Foundation data layer. Is that where we are?
Yeah.
Great. Thank you. So the point of the data layer is twofold: to illustrate and to embody, to build in relational data design best practices And the reason for that is to help establish a solid data foundation for any team or project quickly. And by that, I mean minutes rather than days or weeks. And I hope to show you that in just a little bit. This all started for me years ago when I saw this graphic. Some of you have probably seen this. It's referred to as the software triangle or the iron triangle, where we are encouraged to pick 2 of these attributes. You can have good, fast, and cheap, but you can only have 2 of them at a time. And I didn't care for that at all when I saw it. And I thought there's got to be a way that I can have all 3 of those things. And so the data layer and the Adaptive Application Foundation is my attempt at not settling for 2 out of 3, and in an iterative way, getting to make things better and make things faster. And the takeaway here is that the systems that we build, I believe, should encourage us, not penalize us for learning and improving. We all start somewhere, and we all get better as we do this more. The problem with the way that traditional systems have been built, for me, has always been that once they're built, the money and the time is gone. Oh boy. The money and the time that it required to build them is all gone. Hang on a second, I've got some noise here. Thank you, sweetheart. Thanks. We have a neighbor child in distress or something. Okay. So basically, the idea here is to
Hey, Doug.
try to find. Yes.
I believe the screen was not minimized. Can you try again? Yeah. I'll let you know.
Yeah. Seem to be. It wants to stick, I think.
Yeah.
Okay. How about this?
Okay, that's good.
Okay, thanks. Sorry for the interruption there. But the idea here is to find ways that our systems can be more flexible, less static, and less rigid, and that they can learn and grow along with us. The AAF data layer today consists of a set of standardized, high-quality business models. And business entities, when I talk about entities, are the nouns in the system. They are the people, places, and things that our information systems are intended to manage. There's also a set of SQL scripts for creating database objects or artifacts like roles, schemas, tables, and functions. There's even a set of scripted lookup or reference data that populates these tables once they're created. And there's a RESTful business entity microservice that supports the creation, reading, updating, and deleting, or CRUD operations. And then there's a SwaggerDoc API documentation that also is included. In order to make all this work, there are bash command line scripts that run the PostgreSQL scripts that create all those structures. And then each entity definition includes a number of attributes that are common or shared by each business entity. And I'll show you that in a bit more detail. Let me see if I can make this a little larger for a moment. Make it easier to see. So here we have in the file system, these are the bash scripts that run these SQL scripts. Here are the ones that create the roles. And then there's a script here. An example of one of the scripts is creating I believe this is a person. Yeah. So the person has an ID, has a legal given name and surname, and then it has a, the created by and created at, updated and deleted metadata that we're all used to seeing. The good thing about this is that it is all set up automatically and ready to go. So it takes just a few seconds to kind of create this from scratch using these scripts. And that can really save, as you can imagine, really save a project team a lot of time. And also give our data structures a lot of consistency. If we always come out of the gate with the same set of entities and that are made up of the same attributes, then we can get used to having that stuff there from the very first, from day one. Here we have a screenshot of Postman, which shows what it looks like to make a call to these things. And the IDE, this is built in Java with Spring Boot, and there's a lot built into this that's kind of under the covers. So there are things like it doesn't, at any time you do an operation, it returns the record count of that type of entity. How many of them are there? It does pagination automatically. It does event logging, as you can see here. And so the built-in best practices are a thoughtful business entity analysis and design. These entities have evolved over many years and contain, a fairly complete set of attributes, a complete consistent set of entity data structures and data types. That includes the roles, by the way. And I find that roles are typically underused, that people are, in a hurry to get to coding the actual functionality and features. And so we end up with, a lot of times, with roles that are over privileged. And that can lead to security issues. So also featured here are the relational structures that perform very well. I mentioned a minute ago the metadata set for created, updated, and deleted. We also have ordinal numbers where we can establish an arbitrary sort order. An example of this might be something like if you wanted to show a list of countries, let's say, and you wanted to move one country up to the top of that list, even though it's not in alphabetical order. Since everything has an ordinal number, we can force anything in that data set to the top and established an order for sorting that may not be supported by the natural sort order of alphabetic order or date order. We can also temporarily disable any record. And the system does soft deletes. So when you mark something for deletion, it's not actually removed from the database, but it does disappear from result sets, which means it appears to have been deleted. And then everything has the standard is captured using the standard UTC time zone. Something this leads to is the ability to model literally any system using these entities or nouns, associations of entities, and hierarchies of entities. And with these three tools, we can basically model anything that we come across, whether it's a concrete entity, something that actually exists in the physical world, or whether it's an abstract entity, something maybe in a business context that doesn't, that's conceptual, that doesn't exist in a physical way. As we've said, an entity represents a person, place, or thing. An association relates two different entity types. And an example of that might be a person and that person's email address or addresses, or physical address or addresses. And a hierarchy creates tree structures by, again, creating an association, but in this case, it is two of the same entity type. So Here, if you could imagine an organizational unit or a series of organizational units, like an organization, a region, a campus, a department, and by using parent and child, we can build up tree structures, hierarchical tree structures, and using those three things, we can basically create models, data models of anything that we happen to encounter, anything that our customers ask us to model. Another good reason for taking some time and modeling our data carefully is to avoid, I've heard these called God tables, like God classes in the service layer in the code, which have a little bit of this entity and a little bit of that. And you'll see this often. It's an anti-pattern that's easy to slip into, where we have a little bit about the person, a little bit about their role, perhaps a little bit about maybe the company that they work for, and those really ought to be separated out and modeled independently. And so, again, the value of having this already done is that we don't have to spend a lot of time discussing, thinking, modeling, trying something else. We can basically create these entities and then get on to designing and building the functionality that utilize this data. And it really can be a huge time saver and a source of good quality, consistent data. Also, the service logs, and you'd be surprised how many times I've seen services that have been built that are supposed to log and may do so in a limited way, but the log data doesn't. It's not detailed enough really to help troubleshoot, and in some cases it doesn't. When we deploy these services, let's say to a cloud system like AWS, unless that data has been, unless that logging has been pre-configured, it's very difficult and sometimes not possible without reworking the service to get that log data into a service like CloudWatch, for example. One of the other things that this system does is it actually fingerprints using a hash or a digest for each row. And so if any of the values in that row are changed, it would change the value of that fingerprint. So we can use that cryptographic proof to establish what we sent to a client or what we displayed on request for a client. And we can prove that no one has tampered with those values. In some applications, that's not a big deal. In other applications, you can imagine financial applications or things around security, that can be a very sensitive matter, in the need to be able to prove that can be a very valuable thing. And then finally, we have the idea of correlation IDs. As we move from single operations like CRUD, like create, read, update, and delete, into multi-step process operations, where we might want to do something like create a new person record, create an organization record or update, and then create an employee, which is the association between an organization and that person. If we do that in one operation, a multi-step operation, and we assign the correlation ID to each of those records in each of those different tables, we can study later and understand this one operation resulted in these three changes in these tables. And that's what a correlation ID is utilized for. Any questions here? I'll pause for a minute. Okay. This one, I think is really interesting. We as members of Agile teams, we follow Agile processes all the time as individuals. But what I've found is that few organizations are actually Agile. In other words, just because we as Agile teams are operating in an agile fashion, it doesn't mean automatically that we make that organization agile. Instead, we sometimes are held back by those exact agile processes like sprints, which are typically 2 weeks in length and are filled up a long time ahead of time. So when things change, as they often do, the organization is constrained by the backlog that's already been organized into sprints. And the result of that is that they're unable to capitalize on new opportunities or react effectively to new threats because of the fact that their processes are agile, but the organizations themselves are not. And this is one of the things that result from the lack of a data set, for example, that gives us visibility into the history of this organization, because it wasn't designed from the very beginning, right? And we can add attributes certainly going forward, but that's another sprint or 2 or 3 before we can actually put that new attribute in place. And then we have to wait for the data to be collected for some period of time so that it's statistically significant and valid before we can begin to answer these questions. And the better way to do that, I think, is to capture as much of that data from the very beginning as possible. All right, here's an example of the JSON data that comes out of this system. I mentioned common attributes. So everything in the system, every entity, has an ID, which is a long integer. It's got a UUID, which is universally unique. It's got a subtype ID, which tells you the kind of that entity. So if we were talking about, there's an entity called a geographic unit, and that records in that geographic unit table can represent countries, they can represent states, they can represent any geographic subdivision, and the way that we tell them apart, since they're all stored in the same table, is by the subtype ID. There's a text key, which is a human readable, unique identifier, which really helps when we're looking at data as it moves through the system, or trying to troubleshoot something that something happened, we don't understand why. Here we can confirm the kind of data without trying to look up these numeric IDs, and we can say, oh, okay, this is an entity type of the 3: entity, association, and hierarchy. This represents an entity, and this is an entity type definition. Each of these things has a localized name, a description. The descriptions, by the way, can easily take the place of a data dictionary. So we've saved time on creating a dedicated data dictionary. And if these are kept up to date, we never need to build a data dictionary. In fact, our data dictionary lives in our database and can be queried from the database. Abbreviations, oops. Here's the ordinal I mentioned. It takes on a -1 value by default, and if we change that, then the sort order in the system, the default sort order, I should say, always includes the ordinal. And so if we override that ordinal, we'll see our the rows that we've overridden that ordinal number on move to the top of that sort order. I mentioned earlier, we can temporarily disable or deactivate any row in the database. And rather than deleting it, marking it for deletion, this is a good temporary way to take something out of the result sets by default. Let's say we have a problematic customer that won't pay their bill or that has gotten behind. We can disable that. I was working for an automotive company, and they had a fleet of trucks that would go out, like tow trucks that would go out and pick up used vehicles, and rather than assign them to new new pickups, we could deactivate them for whatever reason. He's not going to, he's going to be gone this week, and so we deactivate that driver or that truck. It's really handy to have that capability and to not have to go through a sprint cycle to create it once the business decides that that would be a handy thing to have. This puts us in the position of being able to say, yeah, it's already there. It's just a data change. It's, how long will that take? Instead of 2 or 3 sprints, we can say, how do you feel about the end of the day? Right. So that's what I mean by minutes or hours instead of weeks or months. Here's the correlation ID I mentioned, and then the complete set of created, updated, and deleted metadata that's collected automatically. We don't have to do anything. Those are all system assigned values, so we don't even have to send them through in the request to create, update, or delete. They just get picked off and created in the back end automatically. Same for the ID, same for the UUID. Most cases, the text key has a default that's good enough that we don't have to assign it. The ordinal has a default. Everything defaults to is active equals true. So really, there's very little data that we have to supply in the requests here. Most of this is done automatically by the framework. And then looking a little bit ahead, the next steps for AAF Data will be a modeler. The entities that I'm going to show you here in a minute were all done by hand, kind of bootstrapping this methodology or this model. There'll be a graphical, a GUI modeler, which builds in a lot of these data modeling best practices, and a publishing service that will actually create the data structures based on the models. Also want to add event streaming for the CRUD events so that it can go out to something like RabbitMQ or Kafka Q, and then people can subscribe to that and react to those events, like, hey, a new employee record was just created or updated, or we just deleted something, and then take action appropriate to that. Data caching, the system performs really well right now. It's very lean and very small, but as the data volumes increase, of course, caching I think is going to give us continue to give us the performance that we're looking for. And then data graphs. Right now, when you ask for a certain kind of entity, you only get that back. Data graphs will enable us in the future to return just about anything that's related, associated with, or hierarchies or subtypes. And then a lot of entities are built up. The more complex ones are built up by combining entities. And so you get entities within entities, and data graphs will help us quickly and efficiently display all of that data. I think that brings me to the last slide. So I want to, we'll get back to the thank you slide here in a minute, but I want to show you some actual data and see what we can do here. I have the service running in Java right now. Here it is. You can see I started it. It's a Spring Boot application, so Java, jar, target, and here's the entity data microservice. So it starts up. It internally caches a bunch of data about the entities that are defined in the system and the attributes that are associated with each entity. So we have some validation, a validation set of data, basically. And then because that's running, we can do things like the service has a health check endpoint that we can hit. And that's just part of the Spring Boot capabilities. Nothing new to write there. We can also get API docs. I think I have a window here. That's PG admin. Oh, 1 second. Oh, sorry. It's this one, the Swagger UI. All right, so it's got a nice, standard, attractive Swagger UI that's built in, which is a nice feature to have. And then we can go back to the database here. I'm using pgadmin, and so right now it's telling us there are 3 records currently in this person table. In the system, -1 always indicates unknown. So that's something that we may not know the value that we want to use long term. We may not know it right now. And so that's an indicator that that may need to be updated in the future. 0 always means none, which means that it's not applicable or whatever. And then here we have just an example person. As you can see, we've got the numeric ID here and a UUID, which is different for each of these. The subtype ID in this case is none, right? That we don't have a subtype for person. And the text key, which is unique, tells us that this is a person entity. It has a subtype of none, and the name, Amy Anderson, is our first and right now only example of a person record. Legal given name is Amy, surname is Anderson, date of birth, and we can see that Amy is a legal citizen of the country geographic unit ID, and in this case that represents the United States. And the locale is in here as well. So we're we're not doing localization yet, but we're positioning for it, which just means we're capturing data about each person, and a couple of the others localization aware entities have this locale ID, so that in the future we could show content in that user's preferred native language, let's say. But there's no code written to do that localization. We're building it into the data because it's fast and cheap to do it now, as opposed to trying to engineer it in or bolt it on later. The ordinal IDs in this case are all the same. Everything's active. Here's the digest that I mentioned. These are fingerprint values that are generated based on all of the values in this row. And we can see that the creation date thing hasn't been updated, nor has it been deleted. So everything, undeleted records take on this end of time value, which is how we can distinguish them. So I'm going to come back over here to Postman, and I'm going to add another value to the person table. You can see here, this is running at localhost 8080. The entity types in this case is person. And then what's all this gibberish here? This is a JWT in the body. And if we pop over and take a look at and decode this in the JWT, we can see that it tells us a lot about the payload of this. We're using the HS256 algorithm. This is the key here in the future would be for a minimal environment. But the really interesting thing here is the payload. This is the AAF Data client, which in this case is Postman. And we're about to do a post on the entity type endpoint. The audience is the microservice. And then these are timings in epoch time. So this expires at a certain, this request expires at a certain time. And the validation of this JWT is what gives us, so people can't like try to send in the same JWT over and over again. In 2 minutes, this will expire. And then the JTI is what ends up being used as the correlation ID. It's just a unique UUID that's automatically generated. And then here we go. We're going to tell it for the person. We're going to give it a subtype of -1. We're going to, instead of Amy Anderson, we're going to create Bill Baker, different date of birth, and so that's what all that means. And if I send it, then we get our 4th person. There are now 4 rows instead of 3. And this is ID number 2. It's got a automatically generated UUID. Bill Baker is what we sent through. The entity subtype we sent through is -1. And then it's picked up everything else as a default, including a new, it's generated or it's calculated a new, sorry, the correlation ID came through as part of the JWT. Oh, yeah. You might notice that digest is missing from this list, but that's intentional. One of the things we can do in the configuration of this system is in application properties. If we want there to be fields that we never return to the end user, we can list them here and they always get suppressed. So the idea here is that digest is an important field. As we said, we might get a summons one day to court to say, your data was incorrect and it made us make a bad decision or a mistake. And we can cryptographically prove that that's not the case. But in day-to-day back and forth, it's just going to take up space in the data stream, right? So just to illustrate that we're capable of doing that, I can suppress the data or the digest values. And then here are all the created at and updated at are the same value. System user ID is the same value, and it has not yet been marked for deletion. We can, what's going on there? Just to show you what a get looks like, I'm getting a different entity type here. This is the entity type itself, which should list all the different entity types in the system. So we have an entity type definition. Here's our entity type attribute. This is an association of entity type and all of its attributes, which tells us the structure essentially of each of these tables that results from this. Here's an entity subtype. There's definitions for all of these in case you want to read what they represent. But this is a longer, just to demonstrate like the result of a longer get with more data. Here's a person that we just created. Nice definition of what a person represents in the system. And so then we can also do an update. And in this system, it's always a patch. And here we're going to, and I'll show you this live. If I replace, whoops, I'll replace all of that, not part of it. This tells us we're going to do a patch now. Remember before it was a post. And we're going to patch Bill to William because Bill's probably not his legal given name. And we're going to patch the surname just to demonstrate that we did it. And we're going to change his birthday. Right now it's 11, 12, 13. I'm going to do it 12, 13, 14 just because it's easy to see. All right, and so now we have William instead of Bill. We've got Baker patched. And we have, what else did I change? Born at. Yeah, there's our 12, 13, 14 date. So it's just that simple. Then the last thing to do is to delete that entity, which is really just sending through another JWT. Sometimes I hear that pronounced as jot. It always struck me as strange. But here, all we're sending through is, yep, that's the delete operation, and here's its correlation ID. And in this case, there is no body because we're sending through here. We're gonna mark this person with an ID of 2, which is our Bill Baker, now William Baker. So we're going to do that, and that's the last we're ever going to see of Mr. Bill Baker, because it is now going to be suppressed as though it had been deleted. We, from outside of the API, a database administrator, for example, could go back in and set that deleted. You can see the deleted at time has now changed to now, just a few seconds ago. And a DBA could go in and set that back to the end of time, but there's no way, intentionally, no way to do it from inside of the API. We don't want people deleting and undeleting things all the time. That's what the temporary active is intended for. So at this point, I'm gonna check in again here. Oops. Stop sharing, maybe. Sorry about that. Any questions? Anything you'd like me to go back to or spend a little bit more time on? If not, I would love it. I'm going to reshare my screen, but only this one. I would love it if is the deck, the presentation, going to be available to people afterwards?
Yes, they will. I believe so. And also, I'm going to share that link here in the group chat so people can open it before leaving the call.
Thank you. Appreciate it.
And
the 2 links here, there's one for a feedback form. If you have some feedback to leave, that would be very appreciated. But the GitHub repository, if you're interested in that, feel free to go out and check it out. All of the source code is there. The scripts for SQL for creating these tables are there. You don't have to use, it's all open source. You don't have to use the whole thing. If you find the SQL scripts useful and you want to use those, be my guest. And if you're interested in participating in the project, love to have your participation in that as well.
All right. Well, thank you, Doug, and thank you again to all the guesters for your time, and Doug for the valuable insights that you share with us. And yeah, as Doug mentioned, please remember that we're always willing to hear from your thoughts to improve our festivals. So please open that link and leave us any feedback that you want to share. And have a great day, everyone. Thank you.
Thanks again for your time, everybody. Have a good day.